Climate change. You've heard the story over and over again. Carbon dioxide is the villain, the Earth is warming, and we're all doomed unless we go green. We've all seen the documentaries, read the headlines, maybe even argued about it at dinner tables. The story feels so ingrained that it's become part of our cultural wallpaper. CO₂ is building up. Greenhouse gases are trapping heat. Ice caps are melting. Polar bears are sad. But here's the twist. What if this story, as popular as it is dangerously incomplete? What if the real enemy isn't the gas, but something far more immediate? See, when you're told the villain is CO₂, you imagine a cartoon bad guy sneaking around like a silent thief. But science isn't a Marvel movie. Villains don't always wear capes. Sometimes the real culprit is hiding in plain sight. So, what if CO₂ is more of a sidekick, while the real villain, the mastermind, is something we've overlooked? Let's find out. Hi, my name is Jacob Sifon-Abasi Anietie, and I'm an undergraduate in Petroleum Engineering. My work extends beyond engineering into astrophysics and climate science, and today, I'm sharing findings that could change how we think about climate change, forever. We've been told that carbon dioxide, or CO₂, which is a byproduct of burning fossil fuels and is classified as an air pollutant, is the leading cause of global warming. And while it's true that CO₂ plays a role in trapping heat, I want you to consider this. The real trigger isn't the gas, it's actually the heat itself, the thermal energy released into the environment. Think of CO₂ as that friend who always tags along at the party. Annoying, maybe even disruptive. But not the one smashing the furniture. The one doing real damage? That's the heat. Let me walk you through an experiment that proves this, and you can try it for yourself, right where you are. Here's what you'll need. First, a block of ice. Second, a CO₂ source, which could be from a gas cylinder or a lab. Third, a hairdryer or any device that emits warm air. Fourth, a notebook or your phone to take notes. And finally, a room at standard room temperature, which is around 25 degrees Celsius or 77 degrees Fahrenheit. Let's get started. First, gently apply carbon dioxide gas directly onto the surface of the ice. Take note of how the ice reacts. Does it melt rapidly or slowly? Now turn on your hairdryer and apply hot air directly onto another piece of ice. This time, observe how fast the melting occurs. What do you notice? Write your results in the comments below. Here's what I found. When carbon dioxide gas was applied, the ice barely melted. Small trickles of water, yes, but slow. When hot air was applied, the ice melted rapidly. Why the difference? The carbon dioxide gas on its own wasn't hot, it was just a gas. But the heat energy from the hairdryer caused a dramatic physical change. That's our first clue. You know, the idea that carbon dioxide causes climate change actually came from the observation that CO₂ traps heat in the atmosphere. But here's the thing, when it's expelled from engines and factories, CO₂ is hot. Not just a gas, but really part of a heat release event. Once it cools down, though, its thermal activity drastically reduces. And honestly, that's the key misconception. So, what's really harming our planet? It's not just the carbon dioxide, it's the heat expelled during combustion, thermal pollution. Even if we remove all the CO₂ from the atmosphere, but, continue releasing heat into the environment through industrial activity, we're still harming the planet. Once CO₂ cools, its physical impact on ice, or any surface, is pretty negligible. Here's the key. We're not just pumping gases into the air, we're actually pumping heat itself into the Earth's systems. If climate change were a crime scene, CO₂ would be holding the bag. But heat would be caught red-handed, with fingerprints all over the place. This is the overlooked piece of the puzzle. Every car engine, every power plant, every air conditioner is constantly releasing waste heat into the environment. And unlike CO₂, which floats around and disperses, heat energy is absorbed immediately by water, air, soil, cities. That's why cities feel hotter than the countryside. Urban heat islands, rivers near factories run warmer, killing fish. Even with lower emissions, local climates keep spiking because the thermal load keeps rising. Now think bigger for a moment. Multiply this by billions of engines, devices, and machines running non-stop around the globe. The Earth isn't just gassing out, it's overheating. If CO₂ is the smoke, heat is the fire. Let's lighten it up for a second. Imagine blaming CO₂ for climate change is like blaming your Wi-Fi router for your bad grades. Sure, the Wi-Fi gave you Netflix, but the heat of procrastination did the real damage. Or think of it like blaming a fork for making you fat. The fork delivered the pizza, sure, but the villain was the greasy double cheese topping. Humor aside, the point is simple. CO₂ has been a convenient scapegoat. But it's time to look at what's actually raising the thermometer. If heat is the real villain, then our entire strategy for fighting climate change might be off target. So, this research is not only about proving a point, it's really about asking better questions. For a long time, we've been pretty obsessed with carbon neutrality. But what if the real goal should actually be thermal balance? Imagine industries designed not just to reduce emissions, but to capture and recycle heat. What if power plants didn't just pump waste heat into rivers, but instead converted it into useful energy? And what if our cities were engineered as thermal sponges, absorbing, storing, and releasing heat safely? Could it be that the solution to climate change lies in managing heat rather than just carbon? What if our technologies focused on thermal balance, not just carbon neutrality? This flips the script. It's not just about lowering carbon dioxide, it's about controlling how much raw heat we allow to accumulate in Earth's systems. This means new technologies, new priorities, and maybe new hope. I want you to do the experiment and share your results in the comments section. If you're in a lab, at home, or have access to basic tools, try it and compare your findings with others. This isn't just about theory, it's real science you can observe and verify. If this blew your mind even a little bit, don't forget to like, subscribe, and share this video. Let's build a community of curious minds testing and observing. Because real science isn't about memorizing, it's about seeing for yourself. And stick around, because this series has more curveballs coming. Up next, is beyond light speed travel possible? What is truly light? What is gravity? What is cold? Do black holes really exist? How to use water to break down carbon dioxide into carbon and oxygen. Do aliens exist? How alien ships cut through space at 90-degree angles. Want access to my detailed research articles? Send me an email. Note: some of these are premium documents due to demand and depth.